welcome to another episode of Exchange from the Couch.
Hey,
I'm Justin, Brent. Thanks for coming.
Right on.
You invited me, so. But we have Mohan here from Rafay. Sorry, I'm going to say it right one time. To talk about Kubernetes enterprise management, multi-clusters. It sounds really cool to be able to do all the management that you have, and I'm excited to dive in. So let's go ahead and start with some intros. Mohan, go ahead and tell us about yourself. Tell us about what Rafay does for everyone and what they can look forward to.
Absolutely, guys. Thank you for having me on the show. I'm Mohan Atreya, lead products and solutions at Rafay. And excited to be here, kind of share how we are helping our mutual customers kind of move faster, be more efficient. So I'd love to kind of talk a little bit about the platform, the company, and how we got started. And there's actually a backstory that's actually very interesting. It's kind of what pulled the core team together. Let's share that if we have time. And then, show the product in action. We will see all of that.
That's awesome. Well, so what is Rafay?
Yeah, so maybe it might be a good time to kind of get into a little bit of the backstory here. So the most of the founding team, we were exposed to Kubernetes, in the very early days of Kubernetes, right? Kubernetes has come along really fast, really quickly in the market, but it's still, people forget it's just 5-6 years old, right? And in the early days, we figured out that, it was, we wanted to deliver our products on Kubernetes or, at that time, a different orchestrator. And we're finding that we had way too many people supporting operations. 50% of our team was just people holding everything together, writing tooling, what I would call as doing undifferentiated work for us, right? And that was kind of a little bit of the calling saying, hey, we got to help other organizations get out of this business if they can, so they can focus on their apps. In some ways, our philosophy and our thought process is somewhat aligned and very aligned with Amazon, because Amazon kind of eliminates the undifferentiated heavy lifting as well for infrastructure. And we are mostly focused on the workflows, making things extremely easy to use, trouble-free to use. So anyone should be able to do it. So imagine me, I'm not a DevOps person or an ops person. I can spin up clusters left, right, and center. I can deploy applications anywhere in the world, right? And it makes me feel powerful. I'm not in the same league as many of the engineers, though. Yeah.
That's really cool, though, that you can just, and I assume when you spin up a cluster, it comes up with, the right set of standards. That's really cool.
Yeah.
So Rafay can spin up clusters and manage clusters. Why would someone use that versus just bringing up an EKS cluster?
Yeah, so you kind of touched on some of those, right? So bringing up the cluster is like 1% of the problem, the larger problem that customers have to face, right? So let's look at this a little bit and let's deconstruct this a little bit. So I want to provision a cluster, easy. Maybe I'm an expert in Terraform or something else. I can spin that up, right? Now, how do I do upgrades day 2? How do I scale things up? How do I even know what the hell's going on these clusters? And it's an interesting comment.
Exactly. It's like you're reading the comments or something. Synchro I don't know how to say that username says, today I start my day with the announcement I have to upgrade my cluster.
Yeah. So this is the day in the life of a lot of people, right? So every customer we work with and speak with, right, they want to get out of this drudgery, right? It's not fun to spend 2 weeks upgrading a cluster from one version to another, or even a few hours. It should be, really easy, right? Then perhaps moving on to the other interesting problems, access control. Kubernetes is not just used by one ops person or DevOps person or one pipeline, right? They want developers to access it. When they have a Sev1 issue, they want anyone to be able to access from anywhere. And I'm gonna, at some point I'll do a demo of one particular feature that we've supported for about 1.5 years. Now, we did not time it with what happened with COVID. Everyone's working from home. No one likes to get on a Bastion or a VPN. It just sucks, right? From a performance and usability point of view. Imagine me being able to touch a private cloak server running behind a security group. It's behind a security group, so I can't reach it, but we can let you cuddle into it with a full-blown audit trail, so you know who did what and when. So that feature, we didn't plan it, as I said, but it took off like a rocket ship. Just because of the situation we are all in, right? Working from home, remote, all over the world. So some of this is, like, how do I access a cluster? How do I let right people access it the right time? So RBAC and Kubernetes is a big challenge, right? With people changing roles, everything moving around. So that's another problem. And Brent, you touched on another problem, which you alluded to, like provision a cluster with the right standard. That is another large challenge for enterprises, right? So we work with organizations that say that, hey, my production cluster for machine learning needs to look like this, right? But nothing is static. It changes tomorrow, right? Tomorrow something new comes out and they keep evolving it. How do they disseminate this inside the company, right? What they find is, another team is reinventing the wheel, learning everything the hard way, and they're duplicating teams and capabilities again and again. They find that very inefficient. So we are nothing more than, how can I share stuff when one team's figured out a formula? Can they share it quickly and easily? Can an enterprise architect team say that, hey, we've created this standard, we'd like everyone to use it, and not just offer that up as a blog post or a Confluence wiki, which no one reads, right?
Right.
But how do I push it out organizationally where a new team can hit the ground running fast? So these are just examples, right? So access, standardizing a cluster, and another thing which our customers kind of pulled us into, and again, being a startup in a young company, we are hyper responsive to ideas that our customers give us. One of the things that has, again, become very interesting is a self-service model. I mean, in the good old days, I guess, you'd go ask an operations person, hey, please give me a cluster. You wait for a week, and you're lucky, and you've fed that person enough or bought that person a pizza or something. Maybe you're first in line. But that doesn't cut it anymore, right? People want stuff fast. And they may not be Kubernetes experts. So a self-service way by which anyone should be able to bring up clusters, not a Kubernetes expert, because they just, I'm the QA person, I just want to deploy an app and test it for 3 hours. How do I do that? So this is self-service model to provision clusters anywhere. Then integrated visibility and monitoring. Sure, there are best-of-breed products in the market, but you don't need that all the time. The analogy I use is, a best-of-breed visibility product. Think of it like an MRI machine. Well, you don't use an MRI machine all the time. Sometimes a thermometer is good enough, right? For basic things. So we provide those kind of basic things so people can get going. And there's a lot more. So I think the message here and the learning we had ourselves as we went through this a few years back is, provisioning a cluster is perhaps the smallest and the tiniest piece of work that someone has to do in this space. It's the rest of it, which is under the water. It's a huge iceberg. And then people land up slowly building out 20 people teams, 30 people teams, just managing and doing undifferentiated work. And then someone comes and says, hey, how is this useful for the company? Why am I reinventing the wheel? Maybe I should just be buying and using a platform which will let me get my job done faster. Long-winded way of saying it, but hopefully that gave an introduction to the company.
Yeah, that's great.
I think a lot of this reminds me just, how it was back in the day where it's like, I needed to host a website, right? Like I needed a Linux server. And like, in some cases, like I had to go buy actual hardware. I had to like pick and choose how much memory, how much CPU I wanted. I had to figure that stuff out. I had to rack it. I had to stack it, all the stuff. I had to plug it in, get network, all that. That was just like, I had to get started to solve that problem of like, I need to publish a website. And then at the end of the day, like I now have this problem of I have a Linux server and like it solved my problem and introduced all the other problems of, oh, someone else wanted to use it. Now I need, you know, Linux users and SSH keys and like I need just some like standard defaults of like, what should my, you know, log rotation be? What should my cron jobs be to like make sure my disk doesn't fill up? Where do I need just like some of those basic health checks of like, you know, maybe it was a production server, maybe the dev server also, like, I don't want to deal with the alerts on it, but I do need some alerts because otherwise I don't know what's the problem. And this is all those same problems. We solve them for the Linux, you know, system world, configuration management, you know, immutable VMs, all this stuff moved into containers. And now we need Kubernetes clusters, and Kubernetes clusters are solving a same problem in a different way because it's larger scale, it's more complex. It has a lot more integration points. And in those cases, like, getting the Linux server was actually, you know, even if it was difficult at first, it was still the easier part of that long tail of managing applications, installing dependencies, all that stuff. And Kubernetes is very similar in that way, where it's like, hey, you need to make some decisions, what your best practices are around how you're getting authentication, who has access to what, just some baseline of things. But once you solve the I need a Kubernetes cluster problem, you have a Kubernetes cluster problem. And especially when you go to multiple, if you have dozens or hundreds of clusters or hundreds of users, like that's not an easy thing to do. And you do have to manage that complexity somehow. So I'm interested to see how you're solving those problems for people at multiple scales, especially at that enterprise scale where it is like, it's not 5 people, it's not, you know, like 10 people. This is probably dozens or hundreds of people, multiple clusters, multiple regions, multiple providers. And how does that work?
Yeah, absolutely. So we'll talk through that. We can, whenever it's convenient for you guys, we can kind of talk through. I can even do a live demo of the product. I
think you'll have to share your screen into our stream, though.
Yeah. Absolutely.
I am curious if there's just before we even get started with the demo, like, are there other tools you built on top of open source tools or things in the Kubernetes community to kind of enable you to do this stuff?
Yeah. So we actually heavy users of a bunch of projects that exist, and we contribute back wherever appropriate. As I said, you know, the way to think about Rafay is what we saw companies do is take a bunch of these projects or initiatives and attempt to stitch them together, because what they were trying to do was create standardized workflows in their organizations, right? And what we're helping them do is help avoid having to build all these bespoke components one at a time. And then, you know, effectively they are building a platform inside the company for something they don't sell. So that's kind of what we are using. So our platform itself runs on Kubernetes. We actually run on EKS in one of the regions in US West. We set this up in a highly available manner. We use a bunch of components in our solution. As I'll do a demo, I'll kind of talk through some of these. We build a bunch. We leverage a bunch. I mean, our whole philosophy is, if there's something good out there, leverage it, contribute to it, support it, versus reinventing it. I mean, like, we build stuff only when there's not an open source technology or a tool that exists that doesn't solve the purpose. If it doesn't, then we have no choice other than build something for that, right? And I'll show, when I show a demo of our Zero Trust kubectl, you'll see something that we had to build from scratch because nothing like that exists in the market. So we had to build something in that space. And Brent and Justin, I'm sharing my screen, right? I'm new to this.
Yeah, I just popped it in.
Yeah, perfect. Should I just switch gears into the platform, and maybe I'll talk about a few customers and kind of talk about a lot of these through a lens of a customer? Will that help?
Yeah, I think that'd be great.
Let's look at it.
Yeah. So I'll just bring up a sampling of our customers. If you go to rafay.co and click on the customer thing, maybe you'll see some names here. Of course, we can only put names of organizations that allow us to share their names. We have an entire smattering that don't want us to share names for a variety of reasons. So this is a sampling of that.
Very familiar with that.
Yeah, familiar from both sides.
Exactly.
Companies that don't want to share their names and companies that would like them to.
Yeah. Exactly. So So in a nutshell, these are some of our customers, and all of them, some of them are very early in their journey to Kubernetes. Some of them are halfway through it, realized the pain and said, oh my God, this is not going to scale. The approach we have, do it yourself. And there were some that are very mature, and they have surgical problems, and they use some specific capabilities from Rafay because they don't want to reinvent the wheel with those problems, right? So let's talk through what are the capabilities that we could talk about. So typically, I kind of touched on it, right? How do I manage the lifecycle of clusters? And that's what everyone's generally familiar with, and the world doesn't end there, right? Very quickly, I'll be showing you some dashboards about how we power that. I'll talk about how we get that data and what a customer lands up avoiding building for that. We'll talk about blueprints. We'll talk about Zero Trust kubectl. We'll talk about how we can achieve separation of duties between app developers and cluster admins. What are interesting ways you can achieve that? And then there are some really boring things for operational personnel that they just don't want to do, but would like to offload to a platform. I like doing backup and restore. I mean, it's never fun, right? Like doing that. You just want to make that work in autopilot. Then finally, an exciting thing, GitOps. How do you do GitOps without all the heavy lifting? So those are some of the things a platform does. And then finally, of course, integrations. This is a big deal for organizations. Everyone here is familiar with the CNCF ecosystem. It's complicated. There's a lot of things in moving parts in the ecosystem.
It's robust.
You know that. And no one wants to reinvent the wheel there again, right? Like tomorrow, if you have to get better, if you have to have a small team that really understands how to use component one in ecosystem, in the CSCF ecosystem, you got to keep adding more and more people to learn that. So what we've done is make those integrations easier to consume, right? And not to consume.
Some people underestimate like how much benefit there is there, because these sort of the platforms and these like Kubernetes distros, you make some of those opinionated decisions for a customer and say, hey, we've tried 10 different things. Here's the one we're going with, and we're going to support it. And that's a big thing for a customer coming in and saying like, hey, we also tried all these things, but we don't know how robust it is. We don't know the long-term options for this. By getting that support from a company, then they can say, hey, if I have a problem, I don't have to like have an expert in that's going to do pull requests upstream. I don't need to dive super deep into like testing all of the options. Reducing the options is a big win for enterprise in a lot of ways, because it's just like, hey, here you go. Here's 20 different things. Here's the 2 we support. Cool. I can save a bunch of time right there. And then long-term support, I don't have to like keep looking at all these options and new things that come in. That's up to you to be able to like, okay, we're integrating with something else and you're going to support it. Is a lot of people don't know how much value there is there.
Absolutely. I think you hit the nail on the head there, right? I think the key thing for a platform provider is to be to offer an opinionated implementation as an option, but do not force feed the other customer. Right? The customer should be able to say, hey, if I use that opinionated implementation, I should be able to eventually do it myself as well. Please do not close that door for me. I will use the opinionated implementation for certain use cases, or maybe for everything, but let that choice be mine, right? Because at some point, that opinionated choice is going to, products are functions of you got to make choices. The vendor has to make choices for the customer. It may or may not be the right choices all the time. So, but do not block the customer. Yeah.
Internally, we have a little phrase that we tag on to the end of all of our big statements. It's always like if we're gonna make a claim or set a direction, it's always ... unless you know better. Yeah. And I love that when the platform sort of here's my opinion, here's what we think is a good practice, unless you know better, and then have that sort of option to dive out and do things your own way, for that particular use case, because there might be an instance where you need something to be subtly different, and it's going to make a much better situation for you if it is that way.
Absolutely.
And as companies grow, they might need specific things that, like, they need a different observability stack, or they need something else that, like, they have to go deep into. And one of the great things here is it's just Kubernetes at the end of the day. So the entire ecosystem of Kubernetes is still available for people to install and to kind of run with. And they might take some ownership over, hey, I want to go a different route or something, but they have that option because this isn't like a customized Kubernetes at the end of the day. It's the same thing with EKS. Like, EKS brings some opinions on how we want to integrate things, but if you want your own, volume plugin or want to manage, CNI or something like that yourself, absolutely, you're able to, and customers can and do that when they need to.
Absolutely.
So, yeah, in the chat, I hate to put you on the spot, Mohan. In the chat, we have another mention. G19 says, do you guys have any automated ideas in the works for upgrading EKS users to new versions of K8s and warning them or alerting them to areas that are being deprecated? Managed Kubernetes seems odd if you leave people on insecure versions. And I want to start by saying we don't leave people on insecure versions. We do move you forward and graduate you up versions. So watch out for that. Definitely pay attention to our version release schedule, and as we deprecate versions, we will upgrade clusters for you. That said, I think that G19 is also asking another question about, like, what is the process like if you want to manage the upgrade, and move your clusters forward in version. Can you show us or walk us through what an upgrade would be like with Rafay?
Yeah, absolutely. Let me, an upgrade itself takes about 30-40 minutes. It's a
Sure.
long process.
You don't have to.
We might not be able to squeeze that in, but let me see if I have a cluster here, which might have been upgraded recently. Let's see. Let's see if there's any here. Okay, so maybe I'll show a history here with a particular cluster. So this cluster was born a long back, and then the things for any user to think about are, actually, that reminds me, Andrew Park from AWS and I actually did a dedicated webinar on EKS upgrade best practices a few weeks ago. Is there on YouTube as well. So if you search for EKS upgrades and Rafay, you'll see it. You'll see the webinar. We kind of walk through the various models, the in-place upgrade strategies, the pros and cons. We talked about blue-green pros and cons. We also talked about canary upgrade workflows. Now, these are all things that we have kind of worked on with our mutual customers and arrived at, putting together strategies that help people not stumble onto the same mistakes someone else might have made, 8 months before, etc. And then productize them so that there's guardrails around it. So let's look at an example. This particular cluster, it's been upgraded before. So I think if you look at this was born 117. Hopefully the font is not too small. Let
us know if it needs to be blown up out there.
Yeah, it was born at 117. It got upgraded to 118. It took 33 minutes, and there were a bunch of things that were automatically performed. Like, if you go look at best practices for EKS upgrades, it's a big laundry list of things that you have to worry about and take care of. What we've done is made that into a one-click experience by embedding all of those into a cookie cutter workflow, right? And I'm showing you history here, right? Like one of the common problems we ran into with people is said, hey, I have a new employee who just started and he's never seen an EKS upgrade before. What happens? What does it look like? And then an auditor comes and asks, hey, prove to me you upgraded this cluster this time. So we actually built this particular feature exactly for those two use cases, right? So you can see the entire history of what has happened on this cluster over its time period. And if you notice here, the upgrade in the control plane is the long pole in the tent. And then the thing that you're responsible for are your add-ons. You have to upgrade them, otherwise the cluster will not be in a healthy state. And then things like being able to do post validations, like making sure no application are harmed in the process. Like everything should come back up. If it doesn't come back up, maybe because it's using some deprecated API, you get an immediate notification and you can do something about it, right? So failure is never silent in an upgrade. And I think I would recommend looking at the Canary and the blue-green upgrade approaches for complex scenarios where SLA is important for the applications and you want zero downtime for anything. So just an example of how easy upgrades can be made. Yeah.
Do you have both those options for this? Looks like an in place, but then you also have a blue-green and a Canary option. That's really cool.
Correct.
Wow.
Yeah.
Yeah, that's impressive.
With Canary and blue-green, of course, there's some work you got to do because the traffic, how you bring the traffic in, is done outside Kubernetes, right? So that we cannot control. So there you'll have to, either play around with the load balancer or DNS and steer the traffic appropriately. Yeah. So let's go back to, I guess we veered into a deep area, but we'll come back to it. So I'm going to talk about perhaps what does enterprise-grade Kubernetes management actually mean, right? So it's not really management; it's really an operations platform, right? So many a times you have customers saying, "Hey, we go ask a customer, how many clusters do you have, and do you know where they are, and do you know who uses them, and do you have any sense of situational awareness of what's going on these clusters?" And people will say, "I have no idea." Or they'll have 5 different consoles and they're stitched together. And we'd ask them, do you have any concept of separation between business unit 1 and business unit 2 without you having to reinvent the wheel? So about 2 years ago, when we started seeing our organizations struggle with that, we said, hey, we're going to build this concept of an isolation boundary called a project, right? So a project in our in the Rafay side, inside the a tenant. So this is a multi-tenant environment. I'm in this tenant called Rafay demos. Organizations can create these isolation boundaries and say that only a certain number of people can access those projects. Let's look at that very quickly, right? So let me go pick this project called QA. Not everyone has access to it. I can manage membership and I can go in and say only these 3 people have access to it, or this group of people have access to it. And I can tie this in seconds with my identity provider, right? No more messing around with complex logic here. You just simply go in and say, maybe use Okta as an example. It is a very popular identity provider. You go set that up, wire it up in seconds using a simple wizard, and then you're in, right? You're kind of tethered your corporate directory where the source of truth for your users exist, as in developers or operations people and the role management, etc. And then you tie that to the system. And then let's see how that access works. Because I think just talking about access management itself for a large, complex fleet of clusters is interesting. Okay. So I'm going to take a very quick example here. I'm going to talk about this user called Chris. Imagine Chris in this company has been told, hey, you can only access the QA project. And by the way, Chris, you cannot mess around with the applications, Chris. We're going to have separation of duties, and you can only manage the lifecycle of these clusters. That's the only job, Chris. And Chris, because you're a privileged user, I'm going to make sure that you are prompted for strong authentication, and I'm going to set that up in Okta as an example. Let's see what that'll look like, right? So, so Chris, I'm going to jump into another profile. Hopefully, this is also being shared. Like all users in the company, Chris, logs into this company, and they log into their identity provider. Rafay is one of the many different applications that the user is trained to use. And then Chris attempts to log in Rafay, because the policy says, hey, you can't get in unless you present this super strong authentication. In my case, I have a YubiKey here. You can't see this here, but I'm going to touch it. And it's plugged into my laptop, and I'm in. Now notice in the previous screen, when I was showing everything in the Rafay demos, I had like tons of projects, right? There were like 20, 30 projects. But Chris does not see that. Chris only sees the QA project, and he's got a particular role called infrastructure admin. That's his role. Remember, separation of duties. How did we get that? Because he belonged to this group in Okta or whatever directory you use, which kind of powered this mapping, right? Now he's in. He can see the cluster. He can do things. He didn't have to worry about anything else. Very simple, right? Now let's talk about access, right? So now he's seeing the graphical console, or I'm seeing this cluster. Now this cluster is running in a colo in San Jose somewhere. It's an upstream Kubernetes. It doesn't matter for us if it's upstream or EKS or anything. It could span hundreds of AWS accounts. Doesn't matter for us. Even though this cluster is running behind a firewall, notice I get this data. So we have visibility and insight into these clusters over a zero trust channel, where the Rafay operator, Kubernetes operator running on that cluster is dialing out on port 443. It's an outbound only connection to our controller and sending all this data. Now you may say, that's really cool, Mohan. What if I want to do a kubectl to the cluster? You show me this nice button here. You have this download kubeconfig.
I was seeing those buttons and I'm thinking, this is going to be cool.
Yeah. So this I'm going to now show you the thing that has been a lifesaver for thousands of people, users of our platform, right? So I'm going to hit kubectl here. We provide the convenience of a web-based shell, so that you don't have to. Yeah, of course, you can also download the kubeconfig if you want to. And let me type something here. I'm just going to type this out. And even though this shell is running here in my browser, I'm sitting here in the San Francisco Bay Area. This cluster is running behind a firewall, but I'm able to talk to it. I'm able to interact with it. You don't need an inbound connection through a Bastion or a VPN and struggle with all of that. And
I'm guessing all of this gets audited and tracked and can be accounted for as well.
Yeah, absolutely. Let's see that very quickly. So now I just did that, right? Chris logged in, he did something, and a typical problem for every organization is answer the question, who did what and when? So notice here, I logged in as Chris Riley, right? So when one of the key capabilities of a platform is what I would call as just-in-time service account creation. So there's no permanently provisioned credentials on the target clusters. And our whole logic is clusters will come and go. We don't care. They are ephemeral in nature in many cases. The user's identity, today Chris might be an admin, tomorrow something else, God knows, right? So a decision is made, a policy decision is made at time of access, and a service account is created for that user on the target cluster just in time, right? And then it's removed because we don't want to leave any dangling credentials. So security teams are absolutely thrilled at this prospect of just-in-time decision-making based on policies they have. So tomorrow they change the policy, they can enforce it across hundreds of the clusters without having to go cluster by cluster and change something. It's a huge lifesaver and a time saver. So you also have auditing. By the way, we can also audit kubectl logs. So just before I logged in as Chris, I guess I was messing around on this other cluster I have. We capture all the things this user has done at a kubectl level. So people can stitch this together, like in their Splunk or something else, and say who did what and when. This is a very important part for people to achieve their SOC 2 compliance and other things.
I just want to go back and make sure that, like, component-wise, I'm understanding all of this too, where this cluster doesn't matter where it is, doesn't matter what Kubernetes. We basically are installing an agent in that cluster so that it can talk back and give these stats to this dashboard. That agent, I'm assuming inside the cluster, needs some elevated privileges to do all this stuff, to get all the resources and create these service accounts on the fly. So that makes sense. A lot of other things have some of this, like clusters have agents installed, just like Linux boxes. We had to install something to collect metrics and all that. That's really cool on this on-demand user provisioning. I'm assuming when they go and they click that button to give me a web console, the agent in the cluster creates a service account, and I'm guessing creates a pod with that service account mounted into it with the secrets to talk to the API server. So at that point, hey, this terminal window is essentially a WebSocket into the pod, so it's an outbound to your dashboard. I connect to the dashboard, I get this WebSocket, and I shell into the pod. I can do everything as there you go, as that service account. So if you do get pods, I'm assuming that's where you are. You're in a pod in the cluster, right?
That's right. Yeah. So you're right. So this is the just-in-time account that was created, right? So literally about 30 minutes before this webinar started, I had provisioned this cluster, and I had attempted to access this cluster just to check on things. And if you notice here, this was created 45 minutes ago. If I switch to the other cluster, again, I might have accessed that earlier. Let's see. Let's try it out. And this autocomplete thing you're seeing there, that's another.
I was noticing and liking that as well.
Yeah, little things that help a developer, right? Because people forget, oh, what is a command, especially for complex commands. They forget what exactly is a particular thing, and the autocomplete goes a long way in helping.
And even some of the security around this, because I mean, this terminal, you have a kube control entry point basically, so I can't do standard bash commands. Can I customize that pod or do things like, if I wanted to have a standard shell, like, hey, give me a shell in the cluster, I'm a cluster admin or whatever? Are those things possible too? Because this is really cool.
Yeah. So let's talk through that. So there's, security, just like AWS, security is job number one for us, right? So we give you a way by which you can run pretty much any kubectl command, but there are things that we cannot defend the user against, so we block them, right? So if the user wants to do complex bash, etc., we don't want that running and messing around. We also don't want to get hacked, right? And for that option, the user, if he wants to run some complex commands, mixing in kubectl and bash, etc., they can download the kubeconfig and do whatever they want, right? But they're running that on their CLI, wherever it exists. Now,
and then at that point, I assume they have to solve the problem of connectivity, getting behind the firewall or whatever.
No, they don't.
That still connects up to you, right, and then down.
Yeah. So exactly. Let's see that. So I just download the kubeconfig, and if you notice here, the user thinks they're connecting to this cluster called prod demo infra, but they're actually talking to a proxy. We advertise that DNS, right? And of course, this proxy, the zero trust kubectl proxy, we can host it, or the customer can host it on one of their clusters, and we can run a network of these. So imagine if I have a team that's in 4 countries, geographically distributed, we can steer the developer or the application or the operations person to the nearest relay and steer them into the cluster with the lowest possible performance impact. In fact, you guys might have noticed some of that in the audit logs. Let me show you that. This is actually a key thing for us. So if you look at the kubectl logs, notice this duration here that I'm highlighting, right? So we measure how long. We are tracking this in a very big way, right? We go tell a customer, hey, your user's kubectl performance is not good, right? We need you to expand the relay network, or we'll do it on your behalf, right? And we can auto scale this and add more nodes to our network, etc. So we get closer to the user or closer to the cluster, because those are the only 2 ways you can solve the problem, right? Of latency. So developer experience, user experience. Like here, for example, if it takes me 0.048 seconds to run a particular command, I mean, it doesn't matter at that point of time, right? Like whether it's 0.04 or 0.1, people won't even notice. But if you see something like 1 second, yeah, we got a problem. We got to go fix that, right? You got to add more capacity in the world, get closer to the user. So we kind of follow the customer's users and follow the clusters because, frankly, they could be anywhere. We can control that.
Yeah, and this relay makes a lot more sense too for things like SSO and all that. Like they don't have to set that up at the cluster. I don't need something in front of the cluster API.
Yeah.
Like it's at that point, it's like no, everything goes through this dashboard, which has all that configuration in one place. So you don't have to do this over and over again in different areas. So all communication goes through here.
Absolutely. Now,
and then
one more question. Sorry, go ahead.
The download cluster config or kubeconfig option, that still, I assume, because you have this proxy mechanism, still gives the ability to dynamically generate the account on the cluster side on demand also.
Exactly.
Right?
Exactly.
That's so cool.
A good resource to look at is if you go to our website, docs.rafay.co is open, and you go under ZTKA, and if you go to the bottom, you see this architecture, which I'm just kind of blowing it up here. So yeah, whether you're coming in through the browser shell or kubectl CLI, you kind of hitting the proxy, which is doing three things. It's authenticating you, it's authorizing you, and it's auditing everything you perform. And when I see you for the first time, it's going to do a just-in-time provisioning of the service account and tell the operator, Rafay operator on the cluster, hey, please go do that. So the user is actually never talking directly to the API server. They're going through a proxy. So you're cloaking your API server.
And you said this, but I want to reiterate it in case anyone in the audience mentioned it. This is something that Rafay can run for us, or we can run it ourselves.
Correct.
Is that correct? Awesome.
Correct.
That's so cool.
We have some hyper-sensitive organizations and financials where they want this proxy to run on their infrastructure for obvious reasons, right? And some organizations offload that to us because we can do a far better job at scaling this out at will, right? Like following the user, following the clusters, and we can do that dynamically. So there are some organizations that care deeply about developer experience and performance, and there are others that are heavily regulated. They have no choice but to deploy this component in Orange on their infrastructure.
Cool.
Yeah. You asked one more question, Justin. I'll just kind of show that. So this data that you're seeing here, right, is being powered partly by Prometheus that we auto deploy on every managed cluster. So I'll come to the blueprint in a second, but I want to touch on this. So one of the common problems we found was people said, hey, I want to see events associated just with one pod. And I'm going to run something like Lens or something like a Kubernetes dashboard. I mean, tell them, sure, go for it. Absolutely. Leverage our kubectl channel and do that. The other option is there's also an integrated experience here where I can go in and say, hey, I want to click on that and see the actions for that particular pod. Or, this is the one that's a sweetheart feature. We saw people, type this complex kubectl command to exec into a particular container. We made that a one-click experience where the user goes one click and I'm looking at my container. I'm in my container, even though I'm, hundreds of thousands of miles away from this cluster. You just saw the performance there, right? Like 1 sec, I can figure out what the hell is going on with my container. Same thing with logs. I can see logs with a particular thing stream back. All to help people do things fast. Now, we're not going to mandate this to you. This is one of the things where, hey, we have something, but if you want your own best of breed, visibility and all of that, by all means, deploy it and run it. Something like a Datadog, or we're actually working on a really sweet integration with an AWS service that's coming up soon called AMP, AWS Managed Prometheus. So we'll be co-launching with that. That'll be very interesting to watch. Now the question that people, sorry,
real quick on that, because I've implemented this at multiple companies now, and two questions come up in my head. Can I get logs for multiple pods at once? Can I go to deployment and say, give me the logs for all pods here at once? I don't know if this is possible in the web UI. I know there's command line tools to do it, and it's like so many developers are like, oh, I need to see all of these pods logs at once to see which one's throwing errors, whatever the case may be.
Yeah, not at that level. You'd have to do that. Yeah, that's a very good use case, though.
And the second thing that I've time and time again I've wanted and I've heard of, I would love a way for if someone execs into one of the pods, that pod should be tainted and destroyed after their shell ends and said like, hey, we don't trust this anymore because someone came into it. And if this is a production workload, who knows what they did? So if a shell ever spawns from here, once that shell process dies, please replace this pod. And there's ways that you could say like, oh no, I actually need this to stick around, whatever, like you can remove labels, that kind of stuff. But it's something that I've had to do at multiple places, and it's a super handy feature. And just if it's not on there already, a feature request from myself.
Yeah, no, absolutely.
I love both those things.
Yeah. And those are actually great use cases. And I think because we have a full end-to-end audit, it's not been a problem for people, right? And because you know what the user did. So there's a full audit trail. So but because Kubernetes makes it so easy, you're absolutely right. Maybe provide a policy where it can be destroyed and relaunched. Yeah, makes sense.
Yeah, that'd be a cool policy to implement. I want to give you a 5-minute warning. We have only 5 minutes left. So is there anything that you want to make sure to cover that we haven't seen yet?
The blueprints I was especially interested in. So if we are covering that, that's great. Yeah,
let's look at that, right? So again, there are blueprints are ways. So there's a default blueprint we provide. Think of a blueprint as an assembly of cluster level add-ons that you want to put together and say that, hey, I want to make sure I use this for every new cluster that comes up. And of course, this can come from a Git repo, right? The classic recommendation we tell people is maintain all these artifacts in a Git repo. You make a change there, we'll go apply it, right? We are the operator that makes sure we take your latest bits from Git and apply it wherever you want. Of course, the rules are slightly different depending on the kind of clusters you have, right? So for example, in the case of EKS, we automatically deploy a node termination handler. Now, that makes no sense in an upstream Kubernetes running on bare metal, but it makes a lot of sense on AWS because AWS provides a service, and especially if you're running Spot, this is a lifesaver. Now, we gradually add more and more of these over time, but we provide a bunch of turnkey things out of the box. Now, an organization may say, go ahead.
Question specifically for the AWS node terminator. How does that work if I have a managed node group? I get the node terminator by default. And so is there like a double dipping here of like it tries to terminate twice? Like how does that work if I already have something that deployed, even say like the kubes state metrics? Like if someone tries to deploy that manually, I have it running twice now. How does that work?
Yeah. So there's some intelligence baked in, right? So because again, AWS has an unopinionated approach here. This makes a lot more sense for the self-managed node groups where the customer is kind of spinning up their own, etc. So it doesn't make sense for certain scenarios. So we step back in those scenarios. So there's some intelligence baked into the whole workflow.
Cool.
Right? Okay. Yeah. Now, the other thing is a company may say, hey, great, you have a default, but I want to build my own as well, right? So let's look at an example here, right? So let's look at this particular example where I had gone in and said, hey, I'm going to put this Argo rollouts and try things out. And how do I do that? So I get to assemble a new version of a blueprint. I give it a version. We all can also bake in PSPs if you want. This is a big deal for most organizations. Of course, it's also complicated now because it's going to get deprecated and transition to another model. Then you can add your add-ons one after another and also build dependencies for that. You can go in and say, put this thing first, then this thing, and then that thing. So that's really important, right? Dependencies. And then you get to choose out of the managed add-ons. Like you may come and say, you know what? I don't care about the ingress. Maybe I don't even care about the monitoring and alerting. I talked about how it's you can turn it off. It's not the customers have options, so you can choose all of that. Create a blueprint.
They're just choosing to outsource monitoring to their customers. It's fine. Like that's like you don't need need a tool to do it. You can just have customers tell you when.
My customers will tweet at me when there's a problem.
Exactly. So and then you go in and deploy the blueprint, a particular version, and push it out to clusters. You can also use it when you're provisioning a cluster. So when you're provisioning a cluster, you can also go in, and I'm just going to make up some names here because we are running short of time. You can say, hey, all clusters have to be born with a particular blueprint. Right? So this is a huge compliance feature for our enterprises where people say, hey, how do I know you guys are doing the right thing? Right? Don't show me a Git repo and ask me to read it. Compliance people can't understand all of that. Right? They want dashboards. So what these organizations land up doing is they use dashboards like this to demonstrate compliance to their internal teams. So I can go in and say, hey, believe me, I don't have a single cluster that's running an end-of-life version of Kubernetes. I have kept them up to date, right? I'm running only 119 and 120 in this fleet here. And then come and ask, hey, how many clusters do you have that are running in our data center versus EKS versus self-managed? Again, you can look at that very quickly. You can look at, am I overutilizing things or underutilizing things? Global view can do that, right? Then top users, like, we had one customer that had something interesting. They had one user that was like, 20 times higher in terms of utilization compared to the rest of them.
I've seen that user. On there? I've been that user. That's the person that cron jobbed their, kube control, like grab the logs for me. Yep.
Yeah. Exactly. So at least it gives people these insights. Right? What is going on? Most people are blind to these things, right? So all these widgets that you're seeing, we actually built this based on, sitting down with our customers and asking them, hey, what would you like to see? What would you use it for? And that drove a bunch of these thinking. Same thing with projects, because what you want to see at a higher level may not necessarily be the same thing you want to see at a project level where you want to go deeper, right? Where you may say, hey, how many namespaces do I have? How many pods do I have?
Now, does this, so I like the idea of projects and lining that up, because a project can live across multiple clusters. It might be, multiple regions, might be whatever. Like, there's lots of reasons a project can do that. Is this looking at like that namespaces? Is that how many namespaces are in those clusters, or how many namespaces are the project using?
Yeah. So in our model, in the Rafay model, everything is multi-cluster. So there can be multiple clusters that live within the context of a project, right? So you're not tied. So the namespaces can live across multiple clusters, right?
And so ideally there, I have one cluster per project, or multiple clusters per project. I'm not using multi-tenant clusters or clusters with multiple projects in them. Is that correct?
Yeah. So we see more and more companies moving away from too many namespaces, too many teams per cluster, and giving them dedicated clusters. And the reason for this is very simple, right? I mean, like, what's the cost of the control plane on EKS? Like, what, $70 per month or less than that? Actually, one of the top reasons why I see people doing that is, application one is lagging, and they are the long pole in the tent from preventing upgrades. They're saying, hey, not everyone's moving at the same speed. I'm going to put the laggards on their own cluster. They can do what they want.
Yep, that coordination's expensive for sure.
Exactly. Yeah. And think about the person who put up that thing, right? And today my day starts with an upgrade. Imagine if that person has to coordinate with 24 application teams running their own namespaces and begging them, have you gotten things upgraded? Or, oh my God, it's going to go end of life. I'm going to wing it, right?
It was the same thing with Linux servers, right? I mean, like I had a box, and as soon as we had 3 apps on there, I'm like, I need to upgrade Ruby for my application, and someone else says, no, I can't. Like it's not possible. And so containers solve that problem, and now multi-cluster Kubernetes is solving the problem all over again.
Exactly, right? So that's
Mohan,
so that's in a nutshell. Yeah, I have a 5-minute thing, right?
We're at our limit.
Okay.
So,
so if you 30 seconds,
okay.
Brent. So just a quick thing, we've talked about maybe 10% of the things that people have to do to solve problems. So think about, how do I manage my applications? How do I do backup and restore? How do I do GitOps? We haven't even talked about that. And that's the scope of the problem that people forget that they're dealing with, which is kind of the reason why it makes sense for them not to build a platform internally and reinvent the wheel. let us help you move faster.
That's awesome. I love that theme. I love that when customers start repeating the same solutions to the same problems, that's when someone should come in and just make that a product and just, eliminate that worry from the customers. We shouldn't all be working on the same set of problems. We should be working on what matters to our business. So that's fantastic. Mohan, thank you for joining today. This has been awesome. I'm really excited to dive into Rafay and find out more about it and poke at it and get my clusters registered into it.
Yeah. So thank you very much, guys.
Justin, thanks for joining, and everyone out there, we'll see you around. Thank you.
Yeah, thanks. Bye.
Yeah. Bye.